this is Colin McGraw, author of the Tickle Monster skill on the Hackster.io website. In the last video, we went over how you could set this game up for yourself, and in this video, we're going to go over how the components work. Now, if you remember, there were three main parts to this skill. There was the account linking page you see here, the skill configuration, and a Lambda function that services requests. Last video, we set the configuration to use account linking, specifically an OAuth2 implicit grant flow. And the way this would typically work is you'd set up an authorization URL here. When the user activated your skill, they'd be directed to a login page. On the login page, they'd enter in their username and password. You would derive some sort of unique token to send to Amazon to associate with the user. Later, Amazon would send that access token back to you in each request the user makes to your skill, and you would use that to do a database lookup, get the user settings, and whatever other information you need to drive the app. Now, we get a little tricky here and make things a little bit simpler, a little more secure, and a little more usable in the process. Now, let me show you how this works. So let's say a user has just activated our skill. They're directed to this page where it says, hey, who's playing? We're going to say Dad, Mom, and little Susie. All right, I'm done. Let's play. Now this page is going to take the user selections, Dad, Mom, little Susie, put them in a comma-separated URI encoded string, and use that as the access token. And what ends up happening is, if we go to the test here, after that point, when the user says, Alexa, ask Tickle Monster, who's next, Amazon sends us those values, Dad, Mom, little Susie, as part of the user's information. Now, you'll notice what's interesting about this approach is we never had to set up a database, which considerably simplifies the code base. We never asked for any username and password, so there's never any username and password for hackers to potentially steal. And from the user's perspective, it's very easy to get up and going quickly. They don't have to go through an email confirmation process. They just say, here's who I want to play. Boom, boom, boom. All right, I'm done. Let's go. With that, let's dig in a little bit to how the Lambda function works. So in our skill configuration, the main intent is this who's next intent. We trigger that by asking Alexa, ask Tickle Monster, who's next. That is going to send this who's next intent over to our Lambda function here. We are going to parse all of the information that comes in. So the important part we care about for now is getting the comma-separated list of participants out from this access token, and the intent name, which again is who's next. And then we get a event response for the who's next intent. And the exact implementation of that is kind of just in this big list of intents at the bottom. So here we are, Alexa, ask Tickle Monster, who's next. And here, if you notice, I get a varied response to this question. So we said Mom, Dad, Susie are participating, but if we just came back with a simple response that says, hey Tickle Mom, hey Tickle Dad, hey Tickle Susie, it's going to get really old really quick. So instead, what we do is have a degree of randomization that not only picks a random participant, but also a random response from a set of templates we have here. So it's going to say, maybe Mom, or I think you should tickle little Susie. And if you'll also notice here, we have these tags built in that are SSML. Let me go ahead and show you how that works here. go over to the test area of our skill, we can hear what these responses are going to sound like. So let's say, I think you should tickle Dad. If it just sounded like this,
I think you should tickle Dad.
that's fine, but we're going to build suspense a little bit here. We're going to add a dramatic pause. So now it says,
I think you should tickle Dad.
And likewise, we have a lot of, let's see, let me think, Dad. Things like that, just to make it fun, spice it up a little bit. And now it's actually probably a good time to segue into how some of the testing works. So if you go down here, you can pretend to ask your skill questions by saying, hey, ask Tickle Monster who's next. What you'll get is the JSON that is sent to the Lambda function as well as the response that was sent back from it. So you can see here, says, I think Mom could use some tickles. If we asked it again, says, you want to know who's next? Little Susie. And again, comes back with these random responses we were talking about earlier. And what you can do with this JSON here is take it and cut and paste it into your Lambda function in order to test. So let's go to configure test event here. And I think the default template is something like this. It's pretty worthless. What you're going to want to do is cut and paste the actual information that was sent, save and test, and you can see the results of the test down here. Now I want to take you over to my VUI diagram in the Hackster.io site to call out a couple of interesting things. So for the most part, we keep the user interaction nice and simple. They ask Alexa, ask Tickle Monster who's next. We respond, I think you should tickle Dad. That's it. Session's over. Should end session is true. We give them time to get the tickling done. And when they want to use the skill again, they say that whole phrase, Alexa, ask Tickle Monster who's next. Now, there are a couple places we don't do that. The first is in the launch or help intent. And in that case, we say help, and we do a few things. The first is to clearly explain the available options. Basically, you can say who's next or say reset the participant names. That's per VUI best practices. That's explained in this document here. I link to it in my Hackster.io page. It's worth checking that out. But the other things we do are offer reprompt text in case they didn't get it the first time. Maybe they didn't hear everything we said or they were confused. We say, oh, okay, I'm going to explain it again. And we keep the session alive by setting should end session false. And what this does is have Alexa continue to listen. So after we say your available options are saying who's next or reset the participant names, they just have to say who's next, and they get this response. Now, the other thing worth calling out is this more complex reset participant names flow where we have a confirmation question in the middle. Are you sure, yes or no? Now, our service is essentially stateless, so what we need to do is set up a mechanism in this information going back and forth to track what question we're even answering. And the way we do that is through these session attributes, which let you store values that are sent back to your service for as long as should end session is false. I'll show you how this works. So if you're saying reset names, then we say should end session is false, and the question they just asked is the reset names intent. And if they answer yes to that question, we can see, oh, the previous question was, do you want to reset the names? And we can, in the Lambda, then make a determination to say, oh, they just asked, do you really want to reset the names? They just answered yes. This is how we want to handle it. And in this case, if they say Want to reset the names? Yes. We do a couple special things. First is to give instructions on how that works, which is basically sending a card to the Alexa app with a link account button you can press to go through the participant setup process again, basically go back to that page. And we do that by setting a special card type. So should reset names is true. And up here in build speechlet response, we look for that. And if we see that, we end up sending this link account card type back in the response here. And that's basically it. There are a few error handling and edge case things that you can discover if you poke around in the code for yourself. But otherwise, just look for the links I provided if you want to dive into deeper detail on SSML or the anatomy of a speechlet response. I provided a few more links in the project document, and let me know if you have any questions. Thanks, guys.